What is going on, everybody? Happy New Year 2022, guys. I hope you and family have a wonderful year and make it successful. And what I want to talk about in this video is the technologies that I want to explore in 2022. Now, I don't get disappointed because none of these technologies are really cutting edge or shiny and everybody's talking about it. No, these are this personal technologies that I want to go after and explore, just because I want to fill certain gaps in my knowledge that these gap gave me trouble in the past. You see, when you want to answer or solve a particular software engineering problem, you'll find yourself you're starting at the high level, and then as you scratch through the problem, you'll find certain obstacles, things you don't know, right? And if you're a good engineer, you're not gonna get an obstacle right away. You're gonna chip at the problem. Oh, it's this because of this. Oh, I better do this because of this. I better do this approach because this. If I do the other approach, I'm gonna run into that problem. And this is where your experience comes from. You cannot get this from reading books or theory. It just comes from experience, in my personal opinion. You'll find yourself chipping away at the problem up until you hit a wall that you say, okay, I really don't know what I do. I was like, what is this thing doing? What is happening here? And that gap, you'll start going into a tangent to learn few things, to understand, to answer these questions. Some people decide to do a quick search, right? And then find a satisfying answer and then move on, right? Some people go even deeper to understand the reason behind the obstacle, and this is how a term I learned called collateral knowledge kind of bubble up, where you learn the knowledge by actually doing a depth search, effectively depth first search, where you go deeper. So you're trying to solve this original problem, but now you end up into a rabbit hole where you go deeper. Some people just find themselves lost and give up after a few hours, and that's basically it. This is the beautiful thing I like to do, right? And I find myself, while solving certain problems or try to answer certain questions, I found these gaps in my knowledge way deep down, right? And I wanted to dedicate 2022 kind of fill these gaps with these fundamental first principle. And whatever I'm going to talk about are these are very low level, fundamentals and first principle. What I found myself, when I understand the basic building blocks, I can build bottom up, and I understand literally anything, when it comes to the software engineering place. But that's only my approach, and I know a lot of people have other approaches. So in this video, I want to separate this video into three parts based on the sector, or I guess the domain, right, of technologies that I want to learn. Databases, networking, and yes, hardware and operating systems. Usually I don't go near hardware just because it's really intimidating to me, and I always kind of brush things like, yeah, it's hardware, it's unstable, it's just hardware, yeah, throw this and it will do its thing. I don't want to do that anymore. I really want to understand how things actually work, right? And that's basically what we'll try to do in 2022. How about we jump into it? So the first part, this section, is databases. Yeah, you might say, Hussein, you have a course on databases. What else do you want to explore in databases? Oh my God. Actually, yeah, I only have a course, but I mostly talk about the fundamentals of database engineering when it comes to very focused on the storage layers, indexes, data structures, and mainly relational workloads and analytical sometimes, right? That's pretty much it. There are other sectors, other problems that have been encountered by big companies, that they have built technologies to solve these certain workloads, if they're database workloads, right? The main two papers that I believe, pave the way to other technologies is basically Amazon Dynamo paper, and the second one is Google Bigtable. So I want to really know how these things work, and I might find out that, I already know how this works. At the end of the day, when I continue to chip away, as I told you, I will find out that it's using things that I already know. But that's what I want to make sure of, because it might be something I don't know, and I want to explore that. Because if I go bottom up and then I can rebuild the entire stack on top, I will understand how Dynamo and Google Table work bottom up. And if I do that, then I can basically understand anything that came on top of Google Bigtable and Dynamo, which is Cassandra, ScyllaDB, Snowflake, I believe, and other stuff that kind of got inspired by these technologies, and many other technologies, But this might answer some of the questions. So this is what I want to explore. I want to explore the distributed aspects of database engineering, in depth. And I want to learn more about it. I want to explore it. I want to see, what am I missing here? Am I missing something? That's the question I try to answer. Well, I might turn out to be missing a lot, or I might turn out to be missing nothing really. And that's the question I want to answer, so I can fill that gap. Does that make sense? So this is the database space. The other part is the networking stack. So I'm pretty comfortable with my networking knowledge, but there are certain things that I find myself brushing off. And the moment I see myself doing that, that means there's an internal fear from, I don't want to approach it. And I find myself hitting that wall in certain networking topics that we're hitting this wall again. What's happening? That means it's like, okay, I'm hitting this wall. Should I brush it off, or should I actually finally, pierce it and start learning it? And these are cell tower communication when it comes to mobile phones. I can't answer certain questions when it comes of the communication through, the mobile technology like 4G, 5G. I don't know how it works. So I really want to explore how me as an engineer, when I send a packet through 5G, how does it actually work through the cell towers, right? And what is exactly happening, and what are the risks, security risks and stuff like that when it comes to tower management, and how do I actually connect? And I might be going into a deep hole here, but at the end of the day, I will reach a stage where I'm kind of satisfied with the knowledge, that I learned. And I'll say, okay, I don't really need to learn more about, I don't know, whatever the physical radio waves itself, but I want to learn about how the transmission is happening. Does that make sense? You'll find yourself, as you acquire more knowledge, you'll get satisfied. And that satisfaction is good enough, right? If you're satisfied with what you know, up until certain point, you answer the question, you don't need to go any further. You can, but usually you don't need to go. And this is how I've been handling the entire channel and now in my knowledge. Once you have this genuine interest of learning things, you want to learn it because you have certain questions that you want to answer, then this is the best thing that can happen to you. And that's basically what's happening to me now with cell tower communication and Bluetooth technology. I want to answer like how these air tags are working, the Apple, how they are doing things. NFC communication, all these things. I really want to know how it works. Genuine interest. And the final part is really the hardware side of things. And I'm lumping the operating system part of here. And mainly because this is really asking a question that I cannot answer yet. And that question is, what is an I/O? And boy, you would think you know, but I don't think a lot of people actually know what an IO is. Because what does that really mean? You know? Boy, if you go deep, and I've been in this for a week now, just learning what exactly is an IO. I can't answer this question. I say, what's an IO? You go to the disk and pull data, but how much? If I said pull me 3 blocks from the disk, and the SSD give me 1 block, 3 second block, third block, is this 3 IOs? But the operating system is just 1 IO to you? Like, because how is it delivered, you know? And what kind of APIs are there in the driver, the SSD? Is it just a single IO? You know, is it asking by a block? Which I found out that there is something called B-read in the operating system, and that is actually pulling block by block. And what is that? Is every single read an IO, or is that a logical read? Right? And the randomness versus sequentially, like, what does that all that mean, right? When it comes to SSD, I'm not really interested in the hard disk anymore, because we don't have hard drives anymore, like very, very little hard drives. So it's all SSD. When it comes to SSD, I know how an SSD works. I know how it stores. I know about the garbage collection, the write amplification. I know these things, but the IO part, I couldn't really answer. And I find myself needing to dive into the operating system land and the driver's land to answer this question. And boy, there's nothing on the internet when it comes to this. There's literally nothing. You cannot find these answers, because these are just so low level questions. And at least from my own research, I'm started downloading some PDF papers and research white papers that goes into these kind of topics. But boy, searching for these things is very hard, you know, because people are interested in certain things. So when you Google SSD IO, you would get, oh, how long the SSD will live. I don't care about that. I know the answer to that, you know. After how many writes does a page takes before it wears out. I know that. I know about word leveling. I know about this. I'm interested in the communication between operating system, so I can answer certain database questions that I couldn't answer. Right? What's a logical? Boy, when you get to that, it just gets so confusing, and it goes back to our topics, like human beings and how they build things. It is by nature disconnected. There is no harmony when it comes to these things. You feel that everything has been built by different human being, and there is no harmony at all when it comes to these things. You know, the way people think are completely different. And if you look at every part, it's a beautiful piece of art, but you cannot connect them together. It's just I know whatever I'm saying maybe might not make any sense, but this is how I feel. I feel like every human is an artist, but the moment you want to communicate these in between two pieces, it just falls apart. Yeah, I know we're working, but I feel that, by God, the hard disk and the SSD, the disk, the operating, there is so much wastage that is going on. The moment I read, I was like, oh my God, why are we doing all this crap? We don't need to do any of this thing. As a database, like backend engineers, if I send an IO to read something, the crap that's going on behind that is a mess. It's a complete mess, you know? And I want to understand this mess so I can hopefully in the future build something that kind of seamlessly. That's why I like Apple. You know, Apple said, F this. We're going to build the entire stack ourselves. They built the CPU themselves. They built the SSD. That's the only way you can build a good product. You cannot build a general purpose thing. You can, but it's not specialized to solve specific workload. You have to build everything from the hard disk itself, the SSD itself, to the driver. You have to build it, to the operating system Sometimes you don't even need an operating system when you're building specialized thing. Think about it. Why do you need an OS if you have a database? If this computer is only going to do database stuff, you don't need a general purpose operating system like Linux or Windows. You want something, you want the database to sit on top of the device directly and talk to the device directly because it knows what it needs. And that's what I want to understand, because I want to explore all that stuff. Yeah. So this is what I'm finding myself learning, and I'm not claiming to know the operating system in and out. I really barely started scratching the surface, and I started having these questions, and this is what I'm going to try to explore. So in 2022, expect, I guess, advanced low-level stuff. So yeah, I don't talk about technology for the sake of the technology itself. I talk about it within a context. I try, at least, you know. So I wouldn't say, okay, B3 is a data structure that everyone needs to learn. B3 doesn't stand for anything. B3 is a balance tree. Some people say it's a some people say it's a buyer's tree, which is the creator. And then, yeah, this is how you create this, and you start going into the B3 itself, and you're just like, wait a minute, okay, what am I learning this again? You lose context, and basically, at least in my case, if I won't learn any of that, right? Because it's like, why am I doing this? Well, what is the purpose of that? But if you put it within a context, within an actual problem, people get interested. It's like, oh, wait a minute. And that's how I noticed the questions in my database course. People actually really interested to know about the B3 because they have certain questions in their mind. Oh, because I put them in that context, right? You put them in the context of a problem, and as they go there, they ask questions even I didn't think about. I was like, oh, wait a second, that's a tough question. So you start seeing people interested in this data structure because they are sitting on top. It's like some students, and even the comment section, they says, wait a minute, why are we doing it this way? It's better to do it this way. And boy, they are right. Yeah, a lot of people challenge what computer scientists come with, and they are good suggestions. You know, that's what I'm telling you guys. I'm telling you that there is this fear of computer science that's created, and you know, it's like oh, it's a sacred cow that shouldn't be touched or questioned. Nah. Some people already started questioning that, and I want you to have this I want you to have this mindset. Just question everything, really. And if you started questioning something, you're probably right. The moment you have certain questions, you are probably most of the time right questioning it, right? And depends on how the teacher or whomever you're asking is answering, then you can actually tell if they know or not. You know, so if they, for example, answered like, "Oh, this is how it always have been." Oh, yeah, this is how it's built. Because if we do it the other way, they'll lead to other problems. Okay, what are these problems? They won't answer you because they don't know these problems, basically. Right? This context is lost. And I'm not really dissing anybody here. It's just telling you that this is how frustrating to students. And I was a student at once, right? And I run into this. And then my favorite thing, oh, this is the best practice. Why is it best practice? Oh, it's always have been done this way and nobody changed it, so it's working. Why challenge it? Well, but yeah, it's working, but it has this side effect and it's a big problem. Yeah, we will solve it with this and this. Yeah, if it's the moment you start, that means you're getting into someone's nerve, and just keep pounding it in a nice way. Obviously, don't get rude, but just go by yourself and explore it. You know, you don't need anybody. You don't need me. You don't need anybody to explore any of this stuff. You know, any question that you have is usually a genuine question, and it just spurs off of curiosity. And some of these questions are, okay, oh, why is it doing this way? Oh, we're doing it this way because of this, right? And sometimes this is a satisfying answer. All right, let's keep this video short and sweet, and I'm gonna see you in the next one. Happy New Year to you again, and stay awesome. Goodbye.